In this example, we're going to look at how to do a paired sample t-test, a paired two-sample t-test in Excel using the data analysis tool. Now, in this example, we're looking at OCBs, that's organizational citizenship behaviors that employees perform. So organizational citizenship behaviors are doing things beyond one's job description to help other people out, like picking up somebody else's mess or bringing coffee in to the office or helping somebody else out on a computer who's having a problem. Just something that's you do good to help other people out. Now, in this situation, there was a office move, and the supervisors or the managers want to find out if the employees are still helping each other out, because now with this office move, they're not sitting as close to each other. So what we have is we have before and after ratings of OCBs. We've got the supervisor rating of 5 employees before the move and the supervisor ratings after the move. And our hypothesis is that OCBs have gone down since the move. Now, this is a one-tailed hypothesis. Because we're just predicting that the OCBs have gone down because they're sitting farther away and people don't help each other out as much. So let's go to our data analysis tool. So we go to Data and Data Analysis, and that should be installed. And you can watch the video on how to install the Data Analysis tool pack if you don't have it installed yet. It's free. It comes with Excel. Press that, and we are going to go to the t-test, the paired two samples of mean. Now this is paired because we've got 2 scores for the same unit of analysis, the same employee. Now we could be measuring husbands and wives in the same couple. We could do before or after scores with an individual, but whenever we have the scores in the 2 groups where each one corresponds to another, we've got a paired sample. And so we'll use the paired two sample t-test in Excel. So I press OK. And now the variable 1 input is going to be the supervisor rating before move. So I select the whole column, including the label in the top. I go to the variable 2 raise, and I choose the supervisor rating after move, select the whole column, and like almost all t-tests that we do, we will put a hypothesized mean difference of 0, and we have labels because we have the words in the top, those are the labels, and the output range, I want it to be on the same sheet, so I click here, then I click in the box, and I will put them here, and I press OK, and we get a lot of data. Let's round it off by going home, number, choose number, so we have 2 decimal points. Let's widen the column so that we can read these. And we've got the different statistics here, the supervisor rating before move and the supervisor rating after the move. And what do we have? Okay, so before the move, it was 7, and after it was 5.6. Okay, so far that fits our hypothesis. People aren't helping out each other as much, but is this significant? We've only got a sample of 5 people. So we've got the degrees of freedom, and we've got the T statistic. 1.6 isn't very high, and we've got the one-tailed p-test of 0.16. So it's not significant because p has to be less than 0.05 to be significant. So how would we write up the results here? Let's look at how we could do this in APA form. We could say OCBs were hypothesized to decrease after a change of office location in a small sample. Then we put n equals 5. OCBs decreased after a move from the mean equals 7.00 to mean equals 5.6. Now it would, let's see, we could report the standard deviation also. Let's do that, because when so we've got the variance from 2.5, and so the standard deviation before, so SD before equals, and then we have to take this equals the we're going to put an Excel command. Remember, the variance is the square of the standard deviation. So I'm going to put equals F9, and then the square root, which is the kind of like that little up arrow. I think it's called a caret, 0.5. And so that gave us a standard deviation of 1.58 before the move. Let me put that there. SD equals 1.58. And then let's do the standard deviation after. And that's going to be the square root of the variance afterwards. That's G, so equals G 9, and then the up arrow 0.5. That's how you do a square root, and it's 2.41. So let's go back to here and put standard deviation equals 2.41. It's always good to have the mean and the standard deviation for any sample that you have, so that you can get an idea of what the distribution is. So we've got the standard deviation there. However, this change was not significant. And then we can report our t-statistic. We've got control I, t, whoops, turn off the italics, space, equals, and our t-stat was 1.16, and we need to report the degrees of freedom. Well, let's go back there, and with a t-statistic, we put the degrees of freedom immediately after the t, and we had 4 degrees of freedom. Now, we don't want those in italics. I'm going to highlight those and turn off italics. Equals 1.6. Then we put p-value, so the p goes in italics, control I, p, control I, space, equals 0.16, period. All right, so that's how we could report this in APA format, that we performed a 2-sample matched pairs t-test on this small sample to see if the OCBs had gone down. And in the sample, they went down, but the difference wasn't significant.